Alright, to begin this lab, we're doing a solubility test. We're going to test benzoic acid, naphthalene, and aspirin, or acetylsalicylic acid, in the solvents water, methanol, toluene, 1 molar sodium hydroxide, and 1 molar HCl. This will help us determine a few things and how we might want to separate the naphthalene and our unknown, which is one of the two acids. So I've gone ahead and done that here, but I'm not going to show you the results, so you can do it yourself. Here we have our SEP funnel and our setup. All you'll need is a ring stand and one of these clamps right here, and you can simply just slide these through and use it as is. I'm going to go prepare the next part, and I will show a demonstration on how to use the separatory funnel in a second. Okay, we weighed out approximately 1 gram of the solid, and I'm going to transfer that to a 100 ml beaker. And notice maybe I spilled a little bit. Make sure you clean up after you use the scale and do not leave it messy. Okay, now I've transferred my 1 gram of unknown sample. This is a 1-to-1 ratio by weight, so that means that half of it should be naphthalene and the other half should be either acetylsalicylic acid or benzoic acid. So the first thing we're going to do is we're going to add 15 mils of DCM, as you can see on the left, and then we're going to add 30 mils of 1 molar sodium hydroxide, and then we're going to add it to the SEP funnel. We want to make sure before we add it to the SEP funnel that this is turned perpendicular. If it is parallel, this is how you drain the fluid out, and I'll pour it in and everything would fall out. So make sure that this is turned on its side, and let's go. Maybe you should do this in an Erlenmeyer so you could stir it easier, but I'm gonna stir it up here with a stir rod, and then I will show you what it looks like in the SEP funnel. Okay, so I didn't want to record audio over that because of the hood noise, so I'm going to explain it right now. So what I did was pour the 1 gram of our unknown in naphthalene and 30 mils of sodium hydroxide and 15 mils of DCM. As you can see, there are 2 layers. In this case, the bottom layer is DCM. Most of the time, water is more dense than an organic solvent, except for when they have chlorine atoms. DCM is the most infamous case. So you need to look up and make sure you know the densities of each respective solvent that you're using. So now what I'm going to do, oh, also, on using the SEP funnel, you saw me first cap it, slowly invert, and then I opened the stopcock by turning the little valve at the bottom, and you heard it hiss. This is because this is a buildup of pressure, and that's why we vent it. And you want to make sure you're pointing your SEP funnel into the hood. If you don't, then you could spray someone or yourself. Okay? So what I'm going to do next is start taking out the DCM. So we have our first 15 mil fraction in there, and I'm going to drain it out and put it into an Erlenmeyer. Now, whenever I'm doing an extraction, I use an Erlenmeyer to represent my organic phase and a beaker to represent my aqueous phase. This way I don't have to write anything down and I know which is which. Again, DCM will be on the bottom, so I will just drain the bottom and put it into the Erlenmeyer. Note that you have to take off the stopcock to do this, or else there's no incoming air to push it out of the SEP funnel. And I've prepared 2 other graduated cylinders with 15 mils of DCM each, which I'll use to extract 2 more times out of the sodium hydroxide solution. Now that we have successfully, well, hopefully, extracted the naphthalene, which should be in the Erlenmeyer, which is the organic DCM solvent, and we've separated our unknown from the naphthalene. Now we need to get the crystals somehow. So first, with the DCM, we're going to use something called sodium sulfate to act as a drying agent and suck out any water possible.
Okay.
All right, so now we're going to use sodium sulfate, our drying agent. This will suck up any water that we have left in the DCM. And we want to add enough so that it is quote unquote free flowing. This is kind of an arbitrary concept and it's very visual. But do you see how the sodium sulfate is able to freely move on the bottom? That's basically free flowing. If it clumps up and there is a lot of sodium sulfate stuck on the walls of the flask and it can't freely move around like that, there's still water in it and you need to add more. So I'm going to add a tiny bit more just for good measure. And we're free flowing.
I'm joining you.
So we're going to transfer our DCM solution into a round bottom flask so we can use the rotary evaporator to drive off the solvent. You want to pre-weigh your round bottom flask before you do this so we can know how much compound we got. AKA, we're going to weigh it again and we'll take the difference and that'll tell us how much naphthalene is in there. So let's do this. And we'll call that 74.16. Okay? Perfect. Glass wool and stuff it slightly, don't do it too hard. We're going to filter this into our pre-weighed round bottom flask. So, like this. In theory, we could wash this again, but I don't think it's necessary for this. Now we're going to go on to the rotovap step. All right, so this is the rotovap. The basic concept behind this is that under reduced pressure, solvents boil at lower temperatures. So, a brief explanation of how this specific system works. If you look in here, we have a bucket of cold water and a little marine pump. And once we turn this on, which we'll start the pump, and you can see that we have water circulating here. So the idea is the gas travels up here, and then it condenses on this cold water basically, and your solvent will end up here while your product remains over there. Okay, all right, so we're going to make sure that we are disconnected from the vacuum. We're going to put our round bottom flask on with a clip, and we're going to reconnect the vacuum slowly, and you'll begin to see evaporation very soon. And we're going to use this machine right here to spin the round bottom flask, increasing the surface area, thus making the process work a lot more quickly. Now we're going to try to lower it down into the water. If it goes any lower, I'm going to have to fill this up a little bit more, but you typically want it in the water because this also helps dissipate any heat. All right, and you can see bubbles starting to form, and eventually those bubbles will travel up here, go to this cold column, condense, and be back down there. While this is running, we're gonna go look at our aqueous solution and process that. All right,
Okay.
is it ready?
Yeah.
Cool. All right, I'm now just measuring out the calculated amount of hydrochloric acid needed. You should have done this in your pre-lab. And we're going to use this to acidify our sodium hydroxide solution. Okay, so we're going to slowly acidify our solution, and hopefully our product will precipitate. We want to slowly do this, and if you watch, you can see it start to precipitate as we add it. Here we go, we're starting to precipitate, and we're going to add the last little bit of hydrochloric acid. Now I don't see very much product formation, so I'm going to go test the pH and maybe add some more. Here's our pH paper. We're just going to get this glass steroid wet and then test it, and then you see this very dark blue, which is indicative of very alkaline solution. So we're going to have to add some more hydrochloric acid. Now we've added a little bit more, and if we test the solution, we can see that we are now acidic and we have crystal formation. We want to make sure that we don't add too much HCl because it will redissolve. Now this is what your sample will look like once it's done rotovapping. As you can see, the naphthalene has covered the walls of the round bottom flask. Now all we have to do is weigh it.